ourselves to get a perfect square trinomial, we have a process for when we want to do that. Now, you will notice here that it says x squared plus bx. That is different than what you're used to seeing, right? Usually, standard form for a quadratic would be ax squared plus bx plus c. That's what we're used to looking for, what we're used to seeing, that sort of thing. That's not an accident that these are different. And you will notice it's just x squared plus bx, no c value. Well, that's because if we want to make sure we have a perfect square trinomial, we need to be the ones picking our c value to make sure that it will factor to the same two things. If you have a c value to begin with, we will need to move that over to get it out of the way. We will not want a c value because we want to find our own. More importantly than that, you will notice this is not ax squared, it's just x squared. If they do not show us a number in front of the x squared, what's really there? A 1. That's not an accident. Completing the square will only work if you have 1 x squared. You cannot have anything but 1 in front of that x squared for completing the square to work. Which makes sense if you think about it, because say it's like 6x squared. Well, if we're trying to get the same two factors, so it's a perfect square trinomial, 6 can't be the same thing. It's either 2 and 3 or 3 and 2, or 6 and 1, 1 and 6. Now, obviously, there are some that you could make work. A 4x squared might be able to work because you can make it 2x and 2x. But rather than list out a rule list of like all the ones you could have and you couldn't have, it's easier to just say you need to have an a value of 1 for this to work out. Now, assuming all of that is true, the way this works is pretty straightforward. Take your x squared plus bx. You are going to add b over 2 squared to it. You are going to add b over 2 squared. Whatever you get from that, the trinomial you have there, you're then going to factor. And assuming you did b over 2 squared correctly, this trinomial will factor to the same two factors every single time. And even beyond that, it will always factor to just x and whatever you got from b over 2. Meaning, for example, let's see, say you had positive 8x there. Well, you would take then your b value of 8, and you would have 8 divided by 2 squared. What is 8 divided by 2? 4. So you would have x squared plus 8x plus 4 squared. Well, we certainly know that 4 squared is 16, which means if you went to factor this, you would be looking for two numbers that multiply to 16, but add to 8. What are two numbers that multiply to 16 and add to 8? 4 and 4. That's what we got for b over 2 right here. Right? We got 4 right here. So it goes down to an x plus 4 squared. That will work every single time. If you don't like that pattern, or if that pattern is causing you confusion, then just factor it normally. I'm just simply pointing out that is a pattern that will always work. So really, you could have gone straight from the 4 squared just to x plus 4 as a quantity squared. You didn't have to do the x method and such because it will always work that way. Okay, again, that's really not a requirement. That's just me pointing out a pattern for you. Any questions on that part? A reminder, I know in the past that I have said you have your choice between, like in this case, I've told you could write it as x plus 4 squared, but it was also okay if you wrote it as x plus 4, x plus 4. That is still true, but for this specific lesson, for this specific process of completing the square, you will always want to write it as a quantity square. It will help you out. All right. Now that's just the process for completing the square. That is not necessarily the process for actually solving an equation by completing the square. These are all your directions for solving an equation by completing the square. I'll give you a minute to write those down real quick. I mean, the difference is what we talked about there was nice, but that was all in theory. That was just an expression. We need to talk about what to do when you actually have an equation, two sides of the equal sign. You need to actually solve out all the way. A little bit more involved when you do that. Talk as you're finishing up writing this. First off, do recognize with the first step, when I'm saying left versus right side, that is a little arbitrary. I don't really care which side you move things over to. The important thing is your x squared and your x term are on one side, and your constant term is on the other side. I think in general, you guys have been trained over the years to move all your variables to the left and all your constants to the right, so I wrote it that way. I think it looks nicer that way. But really, the important thing is you have them split up one side to another, okay? Step 2, like it says there, it is only a possible step. It's only if necessary. If you already have x squared, meaning 1x squared, you're good. But, we've already stated, you cannot have anything but 1 in front of x squared, so if there is something there, you will need to divide that out. And obviously, now that we're talking about equations, whatever we do to one part of the equation, we have to do to the entire equation. So if you have to divide something away from x squared, you're dividing everything by that number. All of that is set up. Steps 1 and step 2 are all just set up. Step 3 is where you actually start doing stuff, actually start trying to solve your way down using that b over 2 squared and all that sort of thing. Okay? So, for example, let's say I give you that equation. X squared plus 6x minus 8 equals 0. This is the part that is kind of weird for completing the square, because if this was 2.3, that's exactly how we want that set up, right? In 2.3, we would have it equal to 0. We're happy with that. If you look back at your 2.3 notes, you probably have a big old star or asterisk or circle where I told you to write it has to be equal to 0. Also, for the record, tomorrow's lesson, when we do quadratic formula, that also is supposed to be set equal to 0 before you start using the quadratic formula. Completing the square is the outlier, the odd one out, where we don't necessarily want it equal to 0. Now it can be, but it a lot of times will not, because remember the point here is we don't like this trinomial. This trinomial is not factorable, right? We need two numbers that multiply to -8 but add to 6. I'm aware 4 and 2 are factors of 8, but it's a -8. So one has to be positive, one has to be negative. That doesn't factor. Even if it did, it would not give us the same two factors. They'd be two different ones. So I don't like that. We don't like that. We want to change that and force this into a trinomial that will factor perfectly. But to do that, we need to pick our own c value. which means we can't have a negative 8 sitting there, so we need to add that to the other side of the equation. Thereby leaving us our own blank spot, our own hole to fill with whatever C value we choose. And now that we have that ability to decide, now we can go in and use our b over 2 squared. What is the b value for this equation? 6. So we're going to add in 6 over 2 squared. But again, this is no longer in theory. This is solving an equation, which means just like every other year that you've learned algebra, you're not allowed to just randomly start adding things in there for the fun of it. If I'm going to add 6 over 2 squared to the left side of the equation, I'm also going to need to add in 6 over 2 squared to the right side of the equation so that it stays balanced. What is 6 divided by 2? 30. So now on the left side, 3 squared is 9. We want to factor that out. X squared plus 6x plus 9. Although, we do know the pattern now. So our b over 2 was 3. So however you factor this, it should come down to just x plus 3 quantity squared. The right side, we're not doing anything fancy with the right side. 3 squared is 9. Just go ahead and simplify that. Go ahead and take 8 plus 9 to give you 17. This is not the answer. This is not our final answer, but I will pause here for a second. Do I have any questions on how we've got to this point so far? Any questions on how I've got to this point so far? Okay. So then, kind of a chance to reset a little bit. Technically, this has completed the square. That is the completing the square part of solving this equation. Now, just kind of pull back a little bit. You're just solving this out like you would any other time. So not special for this lesson, just in general, looking at that equation, how would I go about trying to get x by itself? What would my first step be? Because the goal is to get x by itself, right? And there's two problems with that. I have that 3, and I have that 2 exponent. Square root would be a good place to start. Right? I can't get to that x or to that 3 with that exponent in the way. So the first step would be to get rid of that exponent. And yeah, the opposite of squaring is square root. So we would want to square root both sides. Now the square root and the square are going to cancel each other out, leaving me with just x plus 3 on the left side of the equation. But now let's talk about the right side. First off, what is the square root of 17? Square root of 17, that is correct. I don't want nasty decimals, and 17 prime, so a factor 3 simplification is not going to help you. So it is the square root of 17. But we did introduce that square root. When we introduce the square root, what else do we also have to introduce? A plus or minus. So you actually have x plus 3 equals plus or minus the square root of 17. I know it's hard to get used to, but you cannot forget that plus or minus. Anytime we introduce the square root, if you are solving, there was not a square root to begin with, but you bring one in, you also need to bring in that plus or minus, because we don't know whether it was a negative or a positive that was squared, because they would both give us a positive answer. Any questions on that part, the plus or minus? Final step, then how do I get x by itself? Subtract 3 over. Now I can't actually combine those, because one's a square root and one's outside of a square root. So I will just have to write it as -3 plus or minus the square root of 17. That is better than writing plus or minus the square root of 17 minus 3. Technically, you are still correct either way, but you will never find a math teacher that will appreciate you writing the radical first. It is best to just get into good habits, and good habits would be to write it like that. -3 plus or minus the square root of 17. Any questions on that one?